This lesson covers 1.9 from the textbook and deals with division of algebraic expressions. Now I'm going to break this lesson down into two videos. The first video is going to deal with dividing by monomials, and the second will deal with dividing by multinomials because that involves long division. So for this first video, we're going to talk about dividing by monomials. And the first case we want to look at is what happens if you have a monomial divided by a monomial. Well, similar to what we did with multiplication, we're going to divide the coefficients, and then we are going to divide the like factors by using the laws of exponents. So in this case, when you divide, you end up subtracting the exponents. So in this case, if we want to, we can rewrite it with the fraction bar, which a lot of people feel more comfortable with. If we rewrite this as 14x squared y to the fifth over 7xy cubed, then we can go through and just simply reduce. And so we have 14 divided by 7, which would be 2 and 1. And some people choose to kind of cross things out with the variables as well. I find that gets a little messy and people kind of lose track of things. So I'm just going to do the simplification with the coefficients, which would be 2, which we have left there. And then we have x squared divided by x, which would leave us an x up top because 2 minus 1. And then we are left with a y to the fifth divided by y cubed, which would be a y squared, because we have 5 minus 3 is 2. And we actually don't need the denominator anymore because all that we have left in the denominator is 1. So this is what we get when we divide those two monomials. I want you to pause the video for a second and try this next example. So if you've worked through this example, you would say that 18 divided by negative 10, we can just bring that negative out front. 18 divided by 10, that doesn't reduce all the way, but it does reduce to 9/5. So we are going to be left with a fraction here. Then we say, okay, we've got w cubed. We don't have any w's in the denominator, so that's just going to stay. The next we can go to is the v, since that's up top. V to the sixth divided by v to the fourth is going to leave us with a v squared up top. And then the only one we have left here is that x to the fifth in the denominator, and there's nothing to simplify that with in the numerator. So this is our simplified version. It still looks a little complex, but it's actually the simplified version. And that would be all we would have to do for this problem. So again, dividing monomials is pretty straightforward. We can divide multinomials by monomials as well. Anytime we can always divide by a monomial. It's when we start to divide by anything that has more than one term in the denominator that we need to either go to factoring or long division. So if we look at this, the thing that we have to be very careful with here, and a lot of people forget to do and try to just simplify without doing this first step, the first step is very important. The first thing is that you have to divide each term in the top by the denominator. You can't just pick one that matches with it. You have to do it for all of them because that's what it's saying. That's why we have the whole fraction bar. So in this case, if we have 16x cubed minus 8x divided by 4x, the reason that we put the fraction bar under the whole thing is because we need to divide each piece by that monomial. We can't just pick, we can't just say, oh, 8x divided by 4x is 2. That doesn't work. We need to do it for each piece. So we can say, okay, we've got 16x cubed over 4x minus 8x over 4x, because essentially this is just going backwards from addition and subtraction. So in this case, if we would have had this right-hand side, we would have gone backwards since they have a common denominator and got our numerator. That's another reason why we cannot just simplify one of the terms. We have to simplify both of them. So in this case, 16 divided by 4 is 4. X cubed divided by x is x squared, because we've got 3 minus 1. For our second term here, we've got 8 divided by 4 is 2, and x divided by x. And so you can just leave your answer as this. Yeah, you could factor out a 2 because they have that in common, but we're not going to worry about that right now. So I want you to pause the video and try this next example. So for this example, again, you would need to make sure that you split this up into 3 fractions because we've got 3 terms up top. So we've got 12a cubed over 2a squared minus 6a squared over 2a squared plus 8a over over 2a squared. And again, please remember that you have to split this up for all three pieces. You can't just cancel one of them. So if you look at this first fraction, 12 divided by 2 is 6. A cubed divided by a squared is just a, because we got 3 minus 2 is 1. 6 divided by 2 is 3. A squared divided by a squared is 1, so we're okay there. And then this last one we also have to be very careful with. We've got 8 divided by 2. But then here we've got only an a up top and an a squared on the bottom. So usually we choose to write this as 4 over a, because the highest exponent is in the denominator, the a squared, so we would do 2 minus 1, but since the higher exponent was in the denominator, we put it in the denominator. Another way you could write this is writing it as 4. If you do 1 minus 2, you could write it as a to the negative 1. So both of these are correct answers. I know you've probably heard somewhere along the line that you're not supposed to use negative exponents. Negative exponents are fine. It just depends on the context you need them for. So this concludes the first part of the video. The second part of the video we'll talk about how to do long division when we're dividing by more than a monomial.